Next week, we'll start with convection. Very, very funny, because for the next many weeks, we're going to be talking about how you calculate H, right? So far, I was giving you H, and we had some ballpark values to use. Now we're going to spend a whole lot of time just calculating H. And what we're going to see, again, how H, which is the convection coefficient, in reality is conduction through the boundary layer, and how all those concepts come together. If the Biot number is much less than 1, right? Do we have strong convection or weak convection? Weak convection. So pretty much is the body we're talking about is kind of insulated. How do we solve the problem? What is the approach we have when the Biot number is very small? Lumped capacitance, right? So I haven't, this is lumped capacitance and lumped capacitance here. I haven't said what is going on with this Fourier number here. Right. Then we said, imagine that the Biot number is not much smaller than 1. It's, say, of the order 1, a little bit bigger, right? But not enormously bigger. Here I'm going to say what happens when it's much bigger than 1. But let's go with, if it is not much smaller than 1, what do we do? Yeah, we do the boundary conditions, and you end up with this series solution that is there in front of you, right? So we have a series solution. If the Fourier number was bigger than 0.2, something interesting happened. So let's talk about what happens if it is bigger than 0.2. What do we say about the series solution? You can take the first term, and that's a good approximation. So we would do the first term. And now we said something else too. Now let's say that convection, that Biot number is much bigger than 1. That means intense convection, right? So what else would we know in that case? What we have is that the surface, right, is pretty much the same surface of the fluid. So in this case, we would have the series solution, but we know Ts is more or less the same as T infinity. And in this case also, it's a first term only, Ts more or less the same as T infinity. What I want to do today is to see what happens if Fourier is actually much smaller than 1, much smaller than 0.2, right? And you'll see that beautiful things happen.